So can you see my screen now?
Yes, we can see the screen, yes.
Okay. Hello, everyone. My name is Hemmati, and I'm a postdoctoral research scientist at Columbia University. And today I'm going to talk about the role of human behavior in urbanization and how we can use this fact to achieve communities resilient in floods. Before I get started, I should acknowledge my collaborators, Professors Hussam Mahmoud, Bruce Ellingwood, and Andrew Crooks. So let me start with talking about how we have came up with this idea for this research. In 2017, after Hurricane Harvey and its devastating consequences in the Houston area, a New York Times article came up with this title, How Houston Growth Has Created a Perfect Flood Condition for this City. As you can see in these satellite imagery movies, the city of Houston has experienced unplanned and excessive urban growth in different locations along the city boundaries. In the article, it has been mentioned that this growth has put more people in exposure at risk of flooding, and we need to do something about it. This is exactly what made us to think about this problem. On the other hand, we know that urbanization is highly impacted by development policies such as land use regulations, zoning maps, and also we have people and their locational choices on where to settle will create attractive or repulsive effect on a specific region, and this will shape urbanization through time. The problem here is that if development policies are applied without considering the human behavior aspect of the problem, these policies may not be well implemented or they may result in severe socioeconomic consequences. What we propose here is that we need to first investigate the role of human behavior in urbanization, and development, a policymaker needs to combine all of this information with the proper land use, zoning regulations, socioeconomic incentives to shape urbanization toward less vulnerable areas to floods and build more resilient communities in flood events. With that being said, there are three main research questions we try to answer in this study. First, how can we simulate urbanization through time? Second, how is urbanization affected by human behavior? And finally, how can such tools and information be used for shaping urbanization toward building resilient communities in flood events? To answer the first research question, we have built a behavioral urbanization model. Urbanization consists of two different processes, urbanization inside the city boundary and urbanization at the city boundary. So the idea here is that when a person comes to a region, they have some housing choices inside the city boundary or newly developed housing at the city boundary. So the persistence of these two submodels is really important to know how much growth we need in order to satisfy the housing demand of the community over time. With that being said, the behavioral urbanization model that we have developed consists of two different submodels, relocating model that simulates the dynamic inside the city and the growth model that actually simulates the city expansion over time. To build the relocating model, we have used agent-based modeling. Agent-based modeling is a class of computational models to simulate the action and interaction between autonomous agents. The idea here is that we create artificial population and let them to interact. And it has a lot of application in economics, social science, urban system like pedestrian modeling, traffic modeling, and so on. For building the second part of the model, the growth model, we actually use cellular automata. Cellular automata is a two-dimensional grid over the study region, and it consists of different cells with different states. And these cell states can change through time based on the transition rule, which is a function of different characteristics like accessibility of a cell to the transportation system, suitability of the cell, zoning, and neighborhood. So far, we have talked about building this behavioral urbanization model. Now it's time to talk about the second part of this research. How is urbanization affected by human behavior? To capture that, we actually perform some statistical analysis of housing price market. We know that people usually make a decision on their locational choices based on the price of a building, and price is a bundle of different structural characteristics like building age, bathroom number, bedroom number, square footage, and some neighborhood characteristic like accessibility to education center, park, city center. We want to know which of these characteristics is important the most on the price of the building and consequently on people's decision on where to locate. Before I get into the analysis, I should mention that we have selected the community of Boulder, located at Colorado, as the testbed of this study, because this community is susceptible to floods, and actually there was a huge flood in 2013 in the community, and the community suffered about $1 billion damages, economic losses to the area, and it is a lot for a mid-sized community. And on the other hand, this community is expected to grow and expand over time because of the population growth and economic development that is happening in the region. So as the first statistical analysis, we have performed the analysis of variance. And for that, we have collected the housing price information and also all of these effective variables and fed a function between price of the building and these variables. And it's trying to exclude one term by one term to see how R squared will change. And interestingly, we found out that when we drop the neighborhood quality, it will, when we exclude the neighborhood quality, it will drop the R squared the most. As a second statistical test, we have performed correlation heat map analysis between housing price and these effective variables. And we found out that there are high correlation between housing price and neighborhood quality characteristics. And as a third statistical test, we have performed a principal component analysis. Actually, principal component analysis is a dimension reduction technique for bring out the strong patterns within a large data set. And it's a combination of, so actually, if we take a look at this figure, the dots represent the housing prices, and different arrows represent these characteristics, effective characteristic on the housing price. And the size of arrow represent how important it is on housing price market. And we found out that neighborhood quality characteristics is important more than structural characteristic. And within the neighborhood quality characteristic, which we have defined it as accessibility to parks, lake, highways, a city center, education center. We wanted to see which of these characteristics is important the most. So we performed the same analysis, and we found out that for the city of Boulder, accessibility to education center is important the most. So if I want to wrap up this part, I should mention that people who lives in the city of Boulder care more about the neighborhood quality, and within the neighborhood quality, accessibility of education center is important the most, followed by highway, park, water bodies, and commercial facilities. And I should mention that this ranking is true for city of Boulder. If you want to apply it for another case study, this rank may change. And this kind of makes sense because in the city of Boulder, the city is kind of built upon University of Colorado at Boulder, and people are really high educated there, and they care more about education there. So as a third research question, we try to answer how we can use such tools and information to build resilient communities in flood. So we applied these preferences in the behavioral urbanization model by applying different development policy and mimicking urbanization based on each policy. As a first planning scenario, we actually simulated urbanization without considering human behavior. As a second planning scenario, we will build new educational facilities and shopping center at the northern part of the Boulder, which is the area that is less vulnerable to floods, and encourage development on that direction by increasing the suitability of the area. And as a third development scenario, we actually built new parks and water bodies in the southern part of the Boulder and encourage development on that direction. So here you can see that here is the projection for urbanization for the city of Boulder from 2020 to 2014. And so the colorful area represent how much the city will expand up to 2040, and different colors represent whether the cell will be occupied by residential building, commercial building, industrial building, and so on. And it is really important in flood risk management, and the model can capture all of these changes. And the model can simulate urbanization based on the applied policy, as you can see here. So we actually overlaid this map on top of the floodplain, and we calculated the percentage of growth inside the 100-year floodplain. And we found out that if we use using the policy for education center and shopping center at the northern part of the Boulder, it will put less percentage of growth inside the floodplain compared to just going with the normal development scenario and without considering the human behavior. So if I want to wrap up, I should mention that urbanization is affected by human behavior, and human preferences on the locational choices can be used as socioeconomic incentive to shape urbanization and creating resilient communities in floods. If you're interested to learn more about this study, please refer to the 2 publications that I have about this research. And thank you so much for your attention, and I would be happy to answer any question you may have.